Let us see a few more problems on Z transforms. In this, we'll try to use several properties of Z transforms which we can use here conveniently so that we can solve the problems easily. Let us start with the question number 21. As you see here, this is a problem which consists of this statement. If you see this, there are two parts available in this question. So let us write down them separately. So this I can write as 1 by 3 plus 0.5 1 by 3 n. Okay, so as you see here, there are two parts in this. So we have to use the linearity or superposition theorem, which says that if x1 of n is having a z transform x1 of z and x2 of n is having a z transform x2 of z, then total z transform will be the summation of x1 of z plus x2 of z. So let's take that into consideration. Okay, now let x1 of n be equal to n into 1 by 3 whole to the power of n u of n. Okay. Similarly, I will say x2 of n is equal to 0.5 1 by 3 n u of n. Okay. Now let us say that x1 of n has a z transform x1 of z and this let us say has a z transform x2 of z. Okay. Then x of z will be the summation of x1 of z plus x2 of z. So this is our endeavor. Now we have to calculate x1 of z separately and x2 of z separately, and we have to add those two problems. Now let us solve this. Now let us take the first problem. Okay, let us calculate first x1 of z. x1 of z, if you look at this, it is having this formula 1 by 3 whole to the power of n u of n and n. Now if you see here, there is a multiplication with a factor n. So if you remember our Z transform properties, we have to use the differentiation property to get this step answers. So what does differentiation property say? Let us see first differentiation property and then we'll come back to solve this. So what does differentiation property say? It says Z transform of n of x of n is equal to minus z d by dz of xz. So this is what it says. So we have to use this formula. Why this formula is apt for us? Because here you have n, so I have to use that property. To find out this first, I should know what is the value of x of z. So let us first find out x of z. Once this is known, then I can differentiate with respect to z and multiply with minus z later. So let us break this into two now. Now let in this, what I will do is, first of all let us find out the z transform for this. Okay, then we'll use that formula to find out. So let us find out z for that. So let us say z transform of 1 by 3 n. Okay, so this is nothing but n into 1 by 3 to the power of n when n is greater than or equal to 0. Okay, so we'll put that here. So what does it mean? It means summation from, we know it's starting from 0, so 0 to infinity, 0 to infinity, 1/3 to the power of n, z to the power of minus n. Okay, so let us see this, simplify this further. So I can write this as n is equal to 0 to infinity 1 by 3z to the power of n. Okay, 1 by 3z to the power of n. So that is nothing but this is equal to 1 by 1 minus 1 by 3z. Okay, let us simplify that. That will be equal to 3z by 3z minus 1. So this again I can simplify this as equal to z by z minus 1 by 3. So this is our z transform of this. Z transform of this. Now what is it I have to do? I have to calculate x1 of z. How do I do it? How do I get x1 of z? We have to use this formula and get it here. Okay. Now let us find out x1 of z. So I will write here x1 of z now. x1 of z now will be minus z d by dz of, how much is that? Z by z minus 1 by 3. So we have to calculate this. Now let us do this. Now What is this? Again we have to use the differentiation formula which you all know. Let us just write down once. Okay, d by dx of u by v is v square v u dash minus u v dash. Okay, this is the formula. So let's use that here. So what I'll do is I can write this here. So I write down this here, and this will be equal to, this is z minus 1 by 3 whole square. Okay, that will be z minus 1 by 3 using that formula minus z. Okay, so this will be equal to z by 3 by z by 1 minus 3 whole square. So this is our x1 of z now. So what is ROC for this? The ROC for this is z is greater than 1 by 3. Now this is the x1 of z. Now similarly we have to find out x2 of z. We said this is x2 of n. We have to calculate what is x2 of z. So let us write down what is x2 of z here. So x2 of z can be written as summation, we will take this 0.5 outside, okay, 1 by 3 n z to the power of minus n summation from 0 to infinity, 0 to infinity. Now this is equal to 0.5 into summation n is equal to 0 to infinity 1 by 3z whole to the power of n. Okay, so this I can write as 0.5 into 1 by 1 minus 1 by 3z. Now let us write this here. So that is equal to now x2 of z. I can write this as, okay, 0.5 into 3z by 3z minus 1. So this is equal to z by 2 by z minus 1 by 3, and again ROC is z greater than 1 by 3. Okay, so this is the answer. Now what is the total x of z here? I can write down here. Total x of z now is, you can just add them, x1 of z plus x2 of z. So this is the total answer, and the ROC of this combination is nothing but intersection of ROC1 and ROC2, that is nothing but 1 by 3, which is common between these two. Okay, so this is the answer for this. Let us now look at the next problem, that is question number 22. It's almost similar to what we have done earlier, but it will be simpler in the sense that we are using only one property. Earlier in our case, what are the properties which I have used? We have used not only the linearity or superposition property, but also we have used the differentiation property. But when you look at this problem at the outset, you can just decide what property you have to use, and the property which you have to use again is nothing but the differentiation property. So this is a little bit simple, but let us do it now. The question is, x of n is equal to n of 1 by 4 to the power of n u of n. So this x of n is given, which is equal to n of 1 by 4 to the power of n u n. We have to find out x of z for this, or that is we have to find out the z transform. So when we look at this problem, we have to apply differentiation property because of the presence of this. Because when we said differentiation property, what is that? Differentiation property is applicable when I have an equation like this, where x of n is multiplied by n, then it will be minus z d by dz of x of z. Okay, so this is nothing but our differentiation property which we'll use in our case. So now let us see. First of all, let us find out what is the z transform of this. So let us just write down this 1 by 4 to the power of n, okay, u of n, that means n greater than or equal to 0. Z transform of this will be summation n is equal to 0 to infinity, because this is greater than 1, okay, this is greater than 0, so n is equal to 0 to infinity, 1 by 4 to the power of n, z to the power of minus n. Okay, simple. So what I will do is now we will just rewrite this so that I can get the answer. N is equal to 0 into infinity, 1 by 4z to the power of n. Okay, the summation is nothing but equal to 1 by 1 minus 1 by 4z. Now we have to just simplify this. So this will be equal to 4z by 4z minus 1. So I can rewrite that as z by z minus 1 by 4. So this is my x of z for this. Okay, let us call this as, or let's just call this as x1 of n. Okay, so this will be x1 of z, z by z minus 4. What is the ROC for this? We will calculate ROC anyway greater than 1 by 4. Now, given this, I have to calculate the whole x of z. So, whole x of z is calculable only when I apply the differentiation property. Simple. So, let us apply the differentiation property here. So, now we will just put it here. X of z now is equal to minus z. Okay. Then d by dz of z by z minus 1 by 4. Okay. This is again equal to minus z, z minus 1 by 4 minus z by z minus 1 by 4 whole square. So, this is nothing but, okay, z by 4 by z minus 1 by 4 whole square. This is my x of z. Okay, this is my x of z. And if you see this again, the ROC is greater than 1 by 4. So, this is the answer for this. Somewhere now you have to understand what is the pattern. Okay, when I just take the z trans of 1 by 4 n, the answer I am getting is z by z minus 1 by 4. Okay, so there is a pattern which you have to understand, z by z minus 4. I suggest you calculate for 1 by 3, 1 by 2 and arrive at a general formula. Okay, so this is what we do. And when I differentiate this, I am getting invariably the first order differentiation results in a square term in the denominator. This is what we are getting, and this is the how it is. So ROC is z greater than by 4. And I want you to just go through and understand, is the ROC of this and the final ROC, are they same? Here they appear to be same. Z is equal to greater than 1 by 4. Here also z is greater than 1 by 4. So applying a differentiation property, does it change ROC or not? You have to justify yourself. By solving few more problems, you will be able to understand the point which I am saying. Now let us see problem number 23. So what does problem number 23 says? It is given y of n is equal to x of n minus 1 u of n. Now we have to find out z transform. That means y of n will have a z transform y of z, and that will be equal to z transform of x of n minus 1, okay, u of n. Now we have to solve this problem. Let us solve this. Let us write down, let n minus 1 is equal to k. Okay, because we have this, we will write down n minus 1 is equal to k. That is, what is n? K plus 1. So let us write down here. So y of z now will be equal to, okay, summation n is equal to 0 to infinity, earlier case, okay, x of n minus 1 z to the power of minus n. Now this I will write down by replacing n with k. So what is n here? K plus 1. K plus 1 is equal to 0 to infinity. Okay, what is n minus 1? N minus 1 nothing but k, and z to the power of minus, what is n? K plus 1. So I will write down k plus 1 here. Now again simplify this, no problem, same. Okay, now this will k is equal to minus 1 to infinity, x of k, z of minus of k plus 1. Okay, now we will transform this to a different summation, that is, I will make it summation from k is equal to 0 to infinity, x of k, z of minus k plus 1. Okay, now so see here we are shifting from minus 1 to 0, so we have to add here 1, x of minus 1, z of minus 1 plus 1. Now what will be the answer here? Next step will be, I can just write down this here, this minus k and minus 1, so z minus 1 will bring out here, okay, and then that will be equal to this z of minus 1 bring out here, and then I can write this as x of k, z of minus k, okay, plus x of minus 1. Okay, now this is nothing but z of z inverse x of z plus x to the power of minus 1, because this is our answer for this. Now actually there is a time shifting that is happening. So whenever there is a time shifting, you have to multiply by z of minus 1. That means what is time shifting property? Time shifting property says x of n minus 1 plus or minus 1, z transform of this will be equal to z plus or minus k x of z. Okay, that's what we have got. That this perfect term. Then this is initial conditions which you have to take into consideration. So we got this also here. So this is the answer for this. You have to solve like this. Even though this formula is there, we have to take in that into cognizance, and also some initial cases like this will also be added to this. This is a constant term. See, when we can call it a C or all those things. So we got this answer. Now let us see question number 24. The question number 24 is, there are two signals given. x1 of n is equal to a to the power of n u of n, and x2 of n is equal to minus a to the power of n u of minus n minus 1. So basically they are all same functions a to the power of n, but the places of their existence is different in this case and in this case. Now what is it we have to prove? We have to prove that these two have the same Z transform, whereas the region of convergence are different. So we have to prove this. So now to prove that, let us find out first x1 of z, x2 of z, and see what exactly is the Z transforms. Are they same? Then we'll see what are the different ROCs for them. Okay, let x1 of n be having a Z transform x1 of z. So how do I get x1 of z? x1 of z is nothing but Z transform of x1 of n. Okay, that is equal to summation minus infinity to plus infinity x of n z to the power of minus n, or x1 of n here as you say. But in our case, the function is existing only on the right hand side, so it will be from 0. So I can write down the summation as n is equal to 0 to infinity. What is our x of n? It is a to the power of n, z to the power of minus n. So I can write this here. It is summation n is equal to 0 to infinity a z to the power of minus 1 n. Okay, so we can write this like this. Okay, so what will be the answer for this? This will be equal to 1 by 1 minus a to the power of z minus 1. So I can write this as 1 by 1 minus a by z. So bring it here. So it will be a z by z minus a. This is my x1 of z. Okay, how much is this? Z by z minus a. So what is ROC for this? ROC for this is z is greater than a. Okay, so this is our answer for the first part. x1 of z is z by z minus a, and ROC is z is greater than a. Now we'll write down this there so that we can compare with our the other one. So we'll just write down here x1 of z is equal to z by z minus a, and ROC is ROC1 we can call it as, so that is z is greater than a. So this is the first case. We'll keep that for our record so that we can compare. So this is what we got. Let us see the second case. Let us see this now. Okay, so what is x2 of z for us? x2 of z is nothing but z transform of x2 of n, that is, this is from n is equal to minus infinity to plus infinity minus a to the power of n u of minus n minus 1. So you see here, this is n is equal to minus 1, so it is existing from minus 1. So you have to just change this and bring out the negative sign here. So I can write this as minus infinity to minus 1, okay, a to the power of n. Now this I can write as a to the power of n, z to the power of minus n. This I can write as minus, okay, n is equal to 1 to infinity. So I'll change the signs here. This will be minus n, z to the power of n. So this is what it is. Now what I'll do is summation, I'll shift it to from 0. So what will happen? This will be equal to 1 minus n is equal to 0 to infinity a minus 1 z to the power of n. So this I can write as 1 minus 1 by 1 minus a to the power of minus z. It's nothing but this is equal to 1 by 1 minus 1 by z by a. So that I can write as 1 minus a by a minus z. So this I can write as a minus z minus a by a minus z. Okay. So now this will be equal to minus z by a minus z. So I can write this as z by z minus a. Right? So this is our x2 of z. What is our x1 of z? Same. So did I get the same answer? I got the same answer. x2 of z is equal to z by, so z minus a. The first part is proved. Now what is the ROC for this? Get a little careful here. The region of convergence for this is based on this. So the region of convergence here is z is less than a. So the ROC2 for this, that is z, is less than a. So these two are different. So this is greater, this is less than, so this is what is different. So we have proved ultimately that a given function in fact has the same z transforms, whereas the ROCs, that is the region of convergence for them, is different. So this is what we have proved. Let us see the 25th problem. 25th problem is we have to find out the z transform of x of n given sine of omega n minus 2. So two ways of doing this. One is find out what is the z transform sine omega from the beginning, that's all, and then because there is a shift here in time domain, that will be multiplied by z to the power of plus or minus k, depending upon whether this is plus or minus k time shift. So I will apply the time shifting property z plus or minus k x of z. That is one way. But if you remember, we have done a lengthy process last class where we have taken around 2-3 minutes to find out what are the answers for a cosine function and a sine function given like this. So we'll make use of that our knowledge what we have calculated earlier, and we'll find out what is the x of z for this. So let's start this. Okay. So let's start with what we know. Okay, we know sine omega n, okay, z transform of this is given by what we remember, okay, what we have done earlier. This will be equal to z square minus 2z cos omega plus 1. So this is the result which you have obtained last class, which I was actually insisting on all of you to remember. So I remembered this, so you also must remember. So this is what we have put on here. Now for this we will apply time shifting property. So what is time shifting property for us now? So let us use time shifting property. What is time shifting property says? It says the z transform of a signal which is shifted by a certain time will have a z transform which is equal to z plus or minus k x of z. Now our job is very simple. We know what is x of z. Now you have to just multiply by z plus or minus k. For us k is understandable, it is minus 2. So what I will do is I will write down here directly x of z. Okay. So we know, so we'll write down this x of z. We already know this. Let us write down that first. Z sine omega by z square minus 2z cos omega plus 1. Okay. Then what is it I have to do? I have to multiply by this. So let me multiply this by, what is our k here? 2. So z square, z of minus 2. So let us write down what is the answer here. The answer is z minus 1 sine omega. Let us multiply throughout. So z square minus 2z cos omega plus 1. So this is our answer for this. Simple. Only 2 steps we have taken. We have remembered what is this identity value equal to. That we have used time shifting property. Then we simply put it here. So this is the answer for this question. Let us see question number 26. The question is, as you see here, this is to the power of mod n. So it will have 2 values. What are those values? So this I can write as, okay, this is half to the power of n for n greater than or equal to 0, and this is 2 to the power of n for n less than 0. Okay, this is what we have to calculate. Now again 2 cases here, so I have to find out 2 cases and then just sum up. Okay, so let's just first write down what is x of z here. Let's take this case first. That will be existing from n is equal to minus infinity to minus 1, 2 to the power of n, z to the power of minus n, because existing from minus infinity up to infinity, minus 1, because we have taken this as less than 0, because that's what is given. So this will be up to that point, then plus this will be equal to n is equal to 0 to infinity half n, okay, z to the power of minus n. Now let us take this further. So this I can write as n is equal to 1 to infinity, and I will convert this to the power of minus n, z to the power of n, plus n is equal to 0 to infinity 1 by 2z whole to the power of n. This is a familiar formula which you have done so many times, you can just put it down directly, but this has to be thought a little. So what I have to do is, so this I can write as summation n is equal to 0 to infinity 2 to the power of minus n, z to the power of n minus 1, because we have scaled it, isn't it? It's actually from 1, but we have made 0, so you have to subtract that, plus, okay, summation of n is equal to 0 to infinity 1 by 2z to the power of n. So let us write down here again the same thing. This will be equal to 1 by 1 minus minus 1 plus 1 by 1 minus 1 by 2z. So this actually we have to translate. So I can write this as whole to the power of n. This is what we have written here. So once you put that in formula, this become automatically understandable. So we can simplify this further. So this will be equal to 2 by 2 minus z minus 1 plus 2z by 2z minus 1. This is what we got here. Now how much is this? This we can write it here as 2 minus 2 plus z by 2 minus z, okay, plus z by z minus 1 by 2. So I can write this here, that again, so x of z we can write this as, that I can write as z by 2 minus z plus z by z minus 1 by 2. So this is my x of z in this case. Now actually what we have forgotten is we have to see what are the ROCs for this. For this the ROC is how much? Z is less than 2 here. So the ROC for this is, you can write here, the ROC is Z is less than 2. Okay. What is the ROC for this? Z is greater than half. So what will the total ROC? The total ROC will be the intersection of these two. So my Z lies between 2 here and half here. This is the overall ROC for this given signal. So what is the ROC of this now? The ROC for this is Z is less than 2 here, whereas the ROC for this is Z is greater than half. So the total ROC will be the intersection of these two. So total ROC for this will be Z will lie between 2 and half. So this is the overall ROC. Earlier the ROC term may be removed and then you have to add this here. Let us see question number 27. Question number 27 is x of n is equal to n, a to the power of n, u of n. Now if you see the earlier problems which you have done and you see this problem, basically we have solved some problems. As I said earlier, you have to see a pattern or you have to see an identity which can be applied directly while solving these type of problems. So when we have done some problems where we have seen n into 1 by 3 to the power of n, something n into 1 by 4 to the power of n we have solved. Now we have replaced all that with a letter a to the power of n. Now the solution of this problem will be generic, in the sense a can be any value which you can actually use during the course of your solution of this problem. So let us see this now. Okay. Now again let us say x of z is z transform of x of n. So that is equal to, this is u of n, so it will be existing from 0 to infinity, n of a to the power of n, z to the power of minus n. So now you see a sudden difficulty here when you look at the earlier problems and this problem. Suddenly in your formula there was no mention of n. Okay, now we have an n here. So now we have to look at alternatives as you have been looking at the earlier problems also. The alternative is we have to apply what formula here? N means what? You have to apply, go for a differentiation property. That means we have to break this problem into two parts, where I will find out what is the Z transform a to the power of n first, then I will find out what is the overall Z transform when it is multiplied by n, then I have to use the property, differentiation property. So now let us break this again and then see how this can be done. Okay, now what I will do is, let us see what I can do now is, let us say this x of n is equal to n into x1 of n. Let us put it this way. So now this will help us in first to find out what is the Z transform of this. Let us say that is x1 of z. Once this is known, I'll apply differentiation property. Okay, and then differentiation property, I'll do this. Okay, d by dz of x of z. Now this will give me x of z here. So this is the flow. So what is it we have done? We have taken a small part here and then we said that is x1 of n. Then I have found out x1 of z for that. Then from that I apply a differential property so that you get this whole thing. Then once I do this, I will get my x of z. So we will follow the simple steps now. Now following the simple steps, let us first find out what is x1 of z for this. So x1 of z, I can write this here, that is equal to summation n is equal to 0 to infinity here, n is equal to 0 to infinity, a to the power of n, z to the power of minus n. So this I can write as equal to summation n is equal to 0 to infinity. Okay, we'll take n common. So that will be equal to 1 by 1 minus a z to the power of minus 1. So this I can write as z by z minus a. Alright, this is what we got. Okay, taken this in. Now I have to find out what is x of z. So what is x of z? If you remember the flow diagram I have shown, I have to first find out the x of z which I have found out, then I have to multiply minus z d by dz of that. So this will be equal to minus z d by dz of how much? Z by z minus a. Okay, so that we can do that here. So that will be equal to minus z into z minus a minus z by z minus a whole square. So this will be equal to az by z minus a whole square. So this is my answer, az by z minus a whole square. Now if you look at the earlier problems, earlier problem a was, let us say, 1 by 3 to the power of n, 1 by 3. So a to the power of n will be 1 by 3 to the power of n. So what will be the formula? If you remember this formula, doing the earlier problems will become very easy. So now az, if it is 1 by 3, this will be z by 3, z minus 1 by 3 whole square. Like that you can do this. Okay, so this is my generic formula. You remember this, az by z minus a whole square. This is how we got it. And again ROC will be z is greater than a here. So this is a solution for this type of problems. Question number 28, x of n is equal to n into a to the power of n minus 1 u of n. Okay, let us see how we can solve this type of problems. Again, this is a generic problem. And here again, I should find out what is the z transform for this particular problem. Then, because of the presence of n, it indicates that we have to use the differentiation property. Once the differentiation property formula we know, we can apply this here for what we have calculated. Let us start with this now. Okay, let us say this x1 of n is equal to a to the power of n minus 1 u of n, that will be equal to a to the power of n minus 1 for n greater than or equal to 0. Now let us find out x1 of z for this. Okay, that is the z transform of this is x1 of z. So this will be equal to summation n is equal to 0 to infinity a to the power of n minus 1 z to the power of minus n. So what I will do is I will take out a to the power of minus n here. This will be equal to n summation from n is equal to 0 to infinity a to the power of n z to the power of minus n. Now let us write down this again here, a to the power of minus 1 summation n is equal to 0 to infinity a z to the power of minus 1 whole to the power of n. So this I can write as a in 1 by 1 minus a minus 1. So what is that? Again this I can write as a minus 1 into z by z minus a. This is equal to z by a by z minus a. This is what we got. Now I have to multiply this by n in time domain. So in z transform this will be equal to differentiation. So I can write down that, okay, I can write down x of z is equal to minus z into 1 by a d by dz of z by z minus a. Okay, so that will be equal to minus z by a into z minus a minus z by z minus a whole square. Okay, that will be equal to z by z minus a whole square, because this minus minus become plus, this z here, a gets cancelled, so this is z by z minus a whole square, and the ROC will be z is greater than a. So this is a solution for this problem. Let's see question number 29. X of n is equal to n into u of n minus 1. That means this is the given x1 of n, and this is differentiation of that in z transforms. So first let us write down how much is this. This will be equal to 1 when n is greater than or equal to 1, isn't it? So let us do that now. Now I will find out what is the z transform for this. Okay, let us call it as x1 of z. Okay, that will be equal to, this is 1 from n greater than 1 to infinity. So we can write this as n is equal to 1 to infinity 1 z to the power of minus n. So let us change the summations limits and then take care of the additions which you are making. N is equal to 0 to the power of infinity z to the power of minus n, okay, minus 1 because we are shifting this. So now what will be that equal to? This will be equal to so I can write this as 1 by 1 minus z inverse minus 1. So that will be equal to z by z minus 1 minus 1, that is z by z plus 1 by z minus 1. So this will be equal to 1 by z minus 1. So this is my x of z. Now I have to find out the differentiation of this. So what is that? I can get x of z is equal to minus z d by dz of 1 by z minus 1. X of z is equal to minus z d by dz of 1 by z minus 1. Now when I take the differentiation of this, what I will get is this will be equal to minus z into minus 1 by z minus 1 whole square, that is this is equal to z by z minus 1 whole square, and ROC for this is z greater than 1. This is the answer for this.